Okay, everybody. So today I did want to talk about the Bohr models and the Lewis dot diagrams because I know that we went over that very quickly in class. So I wanted to do a couple of examples with you from your homework. So a couple of things. We already know that the atomic mass is the number of protons, so make sure that those two columns match. Okay, it should be very easy to identify the number of protons because it's the same as the atomic number. Similarly, if I did not give you the atomic number, but you do have the number of protons, then they should, again, be identical, okay? Remember that you can subtract the atomic number from the atomic mass, so 27 minus 13 gives me 14 neutrons. Also, if I did not give you the atomic mass, then you need to add the number of protons and the number of neutrons together because that sum is equal to the atomic mass, okay? So if atomic mass minus atomic number will give me neutrons, then, rearranging that, the atomic number, aka protons, plus neutrons should give me atomic mass, okay? The other thing, your proton number and your electron number for this worksheet should be the same because I did not give you any ions, anything with a charge. So the number of electrons and protons should be the same. And once we identify the number of electrons, then we can go ahead and start filling out the Bohr model. So remember that 2 electrons can fit on the first energy level, but I need a total of 13. So I have to keep going. So 3, 4, 5, 6, 7, 8, 9, 10. Okay, so now the second energy level is full with 8 electrons because that's the max you can put on the second energy level. But I only have 10 electrons. So I need to put 1, 2, 3 on the outside in order to complete the Bohr model. So 13 electrons split up between those energy levels. My Bohr model should look kind of like this. And there's no specific way you have to place the electrons. You just have to have the correct number on each level, okay? They don't have to be paired up. You can just put them around. It doesn't matter as long as you don't go over 2 for the first level, go over 8 for the second level, or go over 18 for the third level. Now, if I look at it, my valence shell, the last energy level that I actually placed electrons on, is right there. And if I look, there are 3 electrons on that last energy level. So those are known as valence electrons, and those are the ones represented by the Lewis dot structure. So for a Lewis dot structure, the way that it works is you find the number of valence electrons, and then that's how many dots you put around the symbol for that element. You pretend like the element's in a box, so don't draw a box, but I'm going to draw one just to kind of show you. You pretend like the symbol is in a box, and I'm going to put 3 electrons around it. Now, you do have to be specific about the placement of the electrons in the Lewis dot structure. The rule is you have to spread out the electrons, so you have to put 1 dot per side before you go back and double up. Now, I don't have to double up for this element because there's only 3 valence electrons, but I do have to make sure that they're all on different sides of the symbol, okay? You should never have more than 8 valence electrons, which brings me to this example right here on the back. So the last one that I gave you was potassium. And if I look at the numbers that I have for potassium, they said that it has 19 protons. So that means that the atomic number is 19, and I should have 19 electrons. If I subtract my atomic mass and atomic number, the difference is 20. So there we go, it has 20 neutrons. And so now I have to start placing electrons. But before I do that, I'm actually going to write the electron configuration for this element. So potassium on the periodic table, if I find it, is actually on the 4th energy level. Okay, if I look, it's on the 4th period going down on the periodic table. And if I wrote the electron configuration, and again, we just, read this going left to right, 1s2, 2s2, 2p6. If I write that out for potassium, it should be 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Okay, so that is the electron configuration for this element. And it actually tells me how many electrons go on each energy level. So on the first energy level, there's 2 electrons. then that energy level is full, right? On the second energy level, I have 2 in the s orbital and 6 in the p orbital. So there's a total of 1, 2, 3, 4, 5, 6, 7, 8 electrons on that second energy level. On the third energy level, the ones that start with 3, I have 2 in the s orbital and 6 in the p orbital. So again, I have 8. 1, 2, 3, 4, 5, 6, 7, 8. And then I have 1 electron on the fourth energy level. So the electron configuration actually tells me that I need to put 1 electron on the fourth energy level, the fourth ring around the nucleus. And so that's the valence electron, and so potassium should only have 1 valence electron. And I know you might be saying, but I thought you had to fill up 18. You will fill up the third energy level with 18 electrons, but according to the way that the electron cloud fills up, we have to put 2 electrons, the 2 4s electrons, on the fourth energy level before we go back and fill in the remaining electrons on the third energy level. So the third energy level will eventually have 18 electrons on it, if your element has that many electrons. It would have the 2 from the s orbital, the 6 from the p orbital, and the 10 from the d orbital. But 4s comes before 3d, so we actually have to put 2 electrons on that fourth energy level before we go back and fill in the 3d level. Okay? So for potassium, instead of putting that last electron on the third energy level, we have to put it on the fourth energy level because that's a 4s electron right there. Okay? I also wanted to show you guys that on your periodic table you have some hints. So there are group numbers on the periodic table written above each chemical family on the periodic table. Not the D section and not the F section, but for the S and P levels, we do have valence electron counts. So if you look above this first group on the periodic table, this is group 1A because they have 1 valence electron. All of their electron configurations end in S1, just like potassium's does. And then they have 1 valence electron, and they get 1 dot on their Lewis dot structure. All of the elements in the second group on the periodic table end in S2. So they all have 2 valence electrons. They're group 2A because their Lewis dot structures are going to have 2 dots, okay? This section we don't worry about right now. When we move over here, the Lewis dot structures for the elements in group 3A should have 3 dots. The Lewis dot structures for elements in group 4A should have 4 dots, 5, 6, 7, and then 8. So the octet rule is that you will not have more than 8 valence electrons. So you should not ever have more than 8. And group 8A is the largest group on the periodic table. Exception to that rule though, helium, okay? Helium only has 2 electrons. So don't put 8 dots around helium, okay? Helium's only going to get 2 dots, but that fills up its energy level because it's on the first energy level, and once it has those 2 electrons, it's full. So this is the exception to the Lewis dot structure rule, okay? You're only going to put 2 dots for helium, but all of the other elements in the noble gas family should have 8 valence electrons.